Write a Java program to check whether the number is prime or not. So the first statement is import java.util.scanner. We need scanner class because we are creating scanner object to take input from the user. Next statement is public class check prime. Public keyword denotes that the class can be accessible from anywhere in the system. Class keyword followed with a class name. This public keyword is optional. If you don't write it, class is still accessible inside the package. And this is a standalone program. Check prime class is not being accessed by any other class outside. So in this case, you don't need this keyword. For more information on access modifiers, public, protected, private, and default, watch video titled Access Modifiers. Next statement is public static void main. We are defining main method. It takes string array as a parameter. Execution starts from here. Now here the first statement is int I. We are declaring a variable named I of type integer. So when this line is executed, memory for variable I is allocated inside stack memory area inside the memory frame reserved for local variables of main method. So memory space for variable I is reserved. Next statement is we are creating object of type scanner. Syntax for creating an object is class name, reference variable name, new keyword, class name and parenthesis and arguments if any. So scanner SC is the reference name equal to new keyword allocates memory to the object. This is a constructor call. What is a constructor? Please watch video titled constructor, scanner, and inside the parenthesis we are passing argument system.in. System.in is used to connect with the input stream, that is keyboard. So when you pass system.in, connection is opened with the input stream. So when this statement is executed, object is created inside the memory, reference variable SC is created on the stack memory area, and actual object is created on the heap memory area. Address of the object is stored inside reference variable SC, and SC points towards the memory location on the heap. Next statement is system.out.println. We are passing text, enter number. So whatever text you pass to println method is printed to the console. So in the output, this text enter number is printed to the screen. We need to tell the user that they have to enter number. That is why we are printing the instruction. Next statement is int num equal to sc.nextInt. NextInt is a method belonging to scanner class. NextInt method reads the input entered by the user in an integer format. For example, user has entered 13. The number 13 is read in an integer format. So this integer value 13 is stored in integer variable num. Now here we are declaring the variable int num. As soon as you declare the variable, memory for variable will be allocated inside the stack memory area. So first thing happens is memory for variable num is allocated, and then the next statement is executed. Next int method reads the input and the number 13 is read in the integer format. This number 13 is stored in variable num. Inside the memory, value 13 will be stored. Next is sc.close. We are creating an object and using system.in we are opening a connection with the input stream. So as a good programmer, it is a good practice to close the opened connection. So once you close this connection, you won't be able to read the input from the user. But in the further program, we don't need to read any input. That is why we are closing connection over here. If the connection stays open, system resources remains engaged. For example, keyboard is a system resource we are using in our program. So if you don't close the connection with the keyboard, it will remain engaged with your program. So you need to close it. But even though you don't write this statement, your program will still work. So for a small program, it is okay to not to write this sc.close. But when you are working on a big project, you need to utilize your memory and resources very efficiently. Next statement is boolean flag equal to false. So we are declaring one more variable named flag, and this is of type boolean. To know more on the variables, please refer to the video titled variables. Boolean variables stores only two values, that is true or false. Here we are declaring the variable named flag. Now this is a user defined name. You can use any name, whatever you wish to. But this boolean variable works as a flag. Flag variable is used to let the program know that a certain condition has met. So this is how we declare flag variable of type boolean, and initial value to this variable we are assigning false. False is a keyword. Boolean variables can have only two values, true and false, and both the values are keywords. So as soon as this statement is executed, memory for variable boolean is allocated inside the stack memory area and value false is initialized to it. So the initial value of variable flag is false. Now here comes the actual logic. Whenever you want to execute some code repeatedly, you need to use loops in your program. We are using for loop. Syntax for loop is for keyword, initialization statement, condition statement, increment statement, and open the curly brackets and write the code inside these curly brackets. So how does this logic work? Now let us have a look on what is prime number. Prime number is a number that is divisible by 1 or it is divisible by the number itself. For example, 5 is a prime number. 5 is not divisible by any other number. It is divisible only by 1 and it is divisible only by 5. So number that is divisible by 1 or only by itself is known as prime number. So in our program, we have to check whether the number is divisible by other numbers also. That decides whether the number is prime or not. For example, 5 is a prime number. We have to check whether the number is divisible by 2, whether it is divisible by 3, whether it is divisible by 4. And if it is not divisible by 2, 3, 4, that means it is a prime number. If it is divisible by 2, 3 or 4, it is not a prime number. This is how the logic is going to work. So let us solve this. So the first statement inside the loop is initialization of the counter variable, that is I, and we are initializing I equal to 2 because we just want to check whether the number is divisible by the numbers between 1 and the number entered. For example, 13 is the user entered number and the definition of prime number is it is divisible by 1 or it is divisible by number itself. So we need to check whether the number is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 and 12. So this thing we are going to check. If 13 is divisible by any of these numbers, then the number is not prime. One more logic we have implemented to reduce the number of iterations. So if you want to do this, your condition should be I less than num. The value of I is 2 and value of num is, we are not writing less than equal to, it is less than num. That means the condition will be checked only till 12. Once it becomes 13, condition will turn false. But we are not doing this logic. We are trying to reduce the number of iterations. And we have given condition I less than or equal to num divided by 2. What is num? Num is the number entered by the user. And the condition we are checking is 13 divided by 2. That is, the integer number should be 6. If we want to find out whether 13 is a prime number, we are checking whether the number is divisible by 3, whether the number is divisible by 4, whether the number is divisible by 5 and whether the number is divisible by 6. So why have we divided the number by 2 and we are checking iterations only for half of the numbers? Because this is a mathematical logic. If the number is divisible up to half of its series, it is a prime number or else it is not a prime number. So you take any number. If you are taking 17, if you divide 17 by 2, the half of it is 8. So you need to check only whether the number is divisible by 2, 3, 4, 5, 6, 7, 8. You don't need to check it for 9, 10, 11, 12 till 16. And we do this so that number of iterations of the for loop are reduced. So let us try to solve this. I is initialized to 2. Value 2 is stored inside variable I. Condition is checked whether I is less than or equal to num divided by 2. Num is 13. When you divide 13 by 2, the integer value you get is 6. Actual float answer should be 6.5, but we are only taking integer value, that is 6. So your iteration will work only till number 6. Now the value of I is 2. Condition is checked whether 2 is less than 6. 2 is less than 6, condition is true. Hence control of the program comes inside the loop and the statement inside the loop is executed. So we need to check whether the number is divisible by any of the number up to number 6. So the number is 13, value of I is 2. In this iteration we are checking whether 13 is divisible by 2. Modulo operator is used to get the remainder. So when you divide 13 by 2, the remainder you get is 1. So value of left hand side is not equal to 0. This is the comparison operator. 1 is not equal to 0. Hence this condition is false. And when the condition is false, control will not go inside the if block. So where will the control go? From here, control will go to the increment statement. And I++ is evaluated. What is I++? I equal to I plus 1. So value of I is 2 plus 1 equal to 3. Now the updated value of I is 3. From increment statement, control goes to the condition. Value of num is 13. 13 divided by 2, the answer you get in integer value is 6. Value of I is 3. So it is checked whether 3 is less than 6. 3 is less than 6, condition is true, hence control of program goes inside. Again, if condition is checked, value of num is 13, value of I is 3. When you divide 13 by 3, the remainder you get is 1. Now 1 is not equal to 0, condition becomes false, hence control of program will not go inside the if block. From here, it will go to the increments and I++ is evaluated. Value of I is 3 plus 1 equal to 4. Now the updated value of I is 4. So inside the memory, 3 is replaced with 4. After the increment statement is executed, control goes to the condition. Value of num divided by 2 is 6. Value of I is 4. Condition is checked whether 4 is less than 6. Condition is true. Hence control comes inside the for loop. Here the if block is executed. Value of num is 13. Value of I is 4. When you divide 13 by 4, the remainder you get is 1. So 1 is not equal to 0. Condition is false. Hence control does not go inside the if block. It is checked whether 13 is completely divisible by 5. So when you divide 13 by 5, the remainder you get is 3. 3 is not equal to 0. Here the condition is false. Hence control will not go inside if block. From here the control of program will go to the increment statement and I++ is executed. So value of I is 5 plus 1 equal to 6. Now the updated value of I is 6. From here control will go to the condition. It is checked. Num divided by 2 is 6. Value of I is 6. It is checked whether 6 is less than or equal to 6. 6 is not less than 6 but 6 is equal to 6. So condition becomes true. Hence the control comes inside the for loop and if block is executed. Value of num is 13. Value of I is 6. When you divide 13 by 6, the remainder you get is 1. 1 is not equal to 0. Here the condition is false, hence the control doesn't go inside if block, it goes to the increment statement. I++ is executed. Value of I is 6 plus 1 equal to 7. Hence now the updated value of I is 7. From here control goes to the condition statement. Value of num divided by 2 is 6. Value of I is 7. Condition is checked whether 7 less than 6. Condition is false. 7 equal to 6. Even this condition is false. So the condition of for loop is false. And when the condition is false, control does not come inside the loop. The loop stops iterating and control of execution goes to the statement that is written after the loop. So from here, control goes to if block. Now what is the condition we are writing inside if block? We have written if keyword and inside the parenthesis you need to write some condition that will written either true or false. If the condition is true, if block is executed. If the condition is false, else block is executed. So this is the basic. Here we are using flag variable. This exclamation sign denotes not. That means whatever is the condition, we are negating it. The value of variable flag is retrieved from the memory. The initial value set over here is false. So we are saying not false. And when we negate false, not false, the meaning of not false is true. So when we write not false, the value is actually true. So over here, the if condition happens to be true. And when the if condition is true, if block is executed. So this statement will be executed. System.out.println num, value of num is retrieved, that is 13. This 13 is printed to the console. Is a prime number is printed to the console. So this is how we find out whether the user entered number is prime or not. So let us take one more example. Suppose the user entered number is 4. Let us solve this. I is initialized to 2. Value of I is 2. Next is the condition is checked. Value of I is 2 less than or equal to num divided by 2. So value of num is 4. 4 divided by 2 is 2. Here the condition is true because 2 is equal to 2. Condition is true, hence control of program will come inside the for loop. Now the if block is executed. Value of num is 4 and value of I is 2. When you divide 4 by 2, the remainder you get is 0. 0 is equal to 0. Here the if condition is true, hence control of execution will come inside the if block. And now what are we doing? We are setting flag equal to true. So initial value of flag is false. If the number is divisible by the iterating number, control comes inside and the value of flag changes to true. So inside the memory, value of flag is modified to true. So this happens when the number is not prime. If the number is prime, if statement is always false and control never comes inside the if block. If the number is not prime, the number is divisible by any of the iterating number assigned to the counter variable I, and the control of execution comes inside the if block and value of flag is changed to true. So this means that user entered number is divisible by some number other than 1 and the number itself. And after the flag is changed to true, the next statement we are writing is break. Break keyword is used to take the control out of the loop. So when break is used inside the loop, control will not go to the increment statement and it will not check the condition. None of the code is executed inside the loop. When interpreter comes across the statement break, control of execution will come out of the loop and go to the next statement written after the loop. And here we have written if not flag. That means now the value of flag is true. So we are saying not true. Not true means it is false. So the condition is returning false. And when the condition is false, control of program goes to else part. When the condition is false, control will not go to the if part. It will go to the else part and it will print system.out.println value of num is 4 is not a prime number. This is how it works when the user entered number is not a prime number.